Right, example 3.4.1, here we're going to draw a histogram. So we're given the heights of 325 students and they have been measured to the nearest centimetre. Part A, draw a histogram to illustrate the above data. So we can see it's grouped data because they're in groups. We also know it's continuous data because it's heights, measurements. Usually when you are measuring the length of something or the amount of time something takes or the mass weight of something, then that is examples of continuous data. Now although they've been rounded to the nearest centimetre, it is still continuous data. First thing I'm going to do, and this is very important, I'm going to look at the groups. If you notice, it looks like there's gaps between each group. First one ends at 154, or that's how it looks, and the second one begins at 155. So if a student was 154.3 centimeters tall, I've gone with one decimal place there might be more than one decimal place. Which group would they go into? Well, remember they've been measured to the nearest centimetre. So for that reason, they would go in the first group, because that's nearest to 154. For that reason, we know there are no gaps between the groups. I've copied this table and put it underneath just so I can add stuff to it. So this first group doesn't stop when we get to 154. It actually goes up to 154.5. We call that the class boundary. Similarly, the second group, it looks like it stops at 164 and the next one begins at 165. It doesn't, it goes all the way up to 164.5. If the student's height is smaller than 164.5, so for example 164.472, then they go into the 155 to 164 group because that rounds to the nearest centimetre, 164. If it's 164.5 or anything bigger than that, then that would round up and they'd go into the next group. So that is the cut-off point. I'm going to put the other boundaries on. So 169.5, 179.5, and also we need the beginning of the first group and the end of the last group. So students have been measured, or rather their heights have been measured and rounded to the nearest centimetre. So looking at this first group, does it start at exactly 130? Well, if a student was 129.712 centimetres tall, then that would round to 130. So anything 129.5 or more would round to 130. When I say or more, I mean 129 point and then something bigger than 0.5 rounds up to 130. So this first group really begins at 129.5, and the final group, see if you can figure out where the last one will end before I draw it on the screen. Okay, I hope you got that right, 199.5. So these are very important. We mustn't have any gaps between our bars on a histogram because it represents continuous data that can take any value in a given range. Now we've identified the class boundaries, we can now start working out the width of each class. We're going to need the width to work out the frequency densities. So I'm going to add another row to my table. So another row to my table for class width. So first class really begins at 129.5 and it really ends at 154.5. So it's these two numbers that we need to be subtracting to find the class width. So we take those away from each other, we get 25. It's a common mistake, and it comes from a lack of understanding of continuous data in histograms to say this class has a width of 24. It doesn't. So notice 25, not 24. Do the same thing with all the other classes to work out their class widths. There we go, that's all the class widths done. Now we have those, we can work out the frequency density of each class. Now we are drawing the histogram ourselves, so we can choose to use a k value of 1. Remember, area is proportional to the frequency. So if you let k equal 1, then area equals frequency. And that makes things simpler. Be careful, if you're given a histogram in the first place partly drawn and you've got to finish drawing it or work out something from it, then k might not equal 1. But I'm going to choose to let k equal 1 on this diagram. So for my histogram in this question, the area of the bar does equal the frequency. So in that case, the frequency density of each bar is going to be its frequency divided by its class width. So another row to the table, frequency density, frequency, which is 55 in this case, divided by the class width, which is 25 for the first group, gives us a frequency density of 2.2. These numbers are easiest written down as decimals rather than fractions. The next group and the third and so on. So finish this row, work out all the frequency densities. There we go, that's the frequency densities done. Now we can start drawing our graph. So let's think about scale. Have a look at how many big squares are going across, how many big squares are going up, and try and use as much of the graph as you can. Right, so I've decided to use 2 for each big square on the vertical axis. So I counted there were 6 of them, and my largest frequency density was 12, so it made sense to go up in 2s. Make sure you label your axes as well. So the vertical axis is frequency density, which in this case is actually number of students per centimetre. You don't need to put that bit on, but it's number of students per centimetre. On the horizontal axis, I counted there were 1, 2, 3, 4, 5, 6, 7, 8 big squares, and by considering the height data, I could use, well, the whole of the graph paper. If I put 130 here and then go up in tens. Something I don't recommend is putting on the thick lines, so that these vertical and horizontal thick lines, decimal numbers. So don't put 129.5 there and 139.5 there. Don't do that. It makes it much harder to read the graph. So the way I've done it, multiples of 10 on the thick lines, and then every small line in fact, I've just counted all the small lines going across, and there's 7 of them. That's horrendous. I think something's gone wrong on this graph paper when we've zoomed in or zoomed out and put it into the notes booklet. It should be 10 little squares going across, not 7. So something's gone wrong with the technology there. That's our fault. We apologise for that. But in general, there should have been 10 little squares going across, like on normal graph paper. You'd never have 7 across. So each little square should have represented 1. Apologies for the appalling graph paper. Anyway, regardless of the appalling graph paper, I'm going to draw the histogram now. So it's all ready to go. Oh, one other thing, on the horizontal axis, because there's a shift in the scale, so at the vertical axis the height would have been 0, but then of course we ignore all the numbers from 0 up to, well, just before 130. So this little squiggle represents that. So there's a shift in the scale, but then each big square is worth 10 after that. So now I'm going to draw all of the bars on the histogram, being careful to draw them at the boundaries of each class. So this first bar will start at 129.5 and finish at 154.5. Now I know you're going to struggle because of this awful horizontal scale where each little square unfortunately isn't worth 1 here. In fact, it might look different on the paper copy. Hopefully your paper version of this graph paper has 10 little squares going across. If it doesn't, again, we apologize, but I can only see 7 little squares going across. So I'm just going to do the best I can, but make sure you draw the beginning of each bar and the end of each bar at the boundaries, so the 129.5, 154.5 and so on. Right, so I've drawn the first bar, like I said, starting at 129.5 going up to 154.5, which unfortunately, because of this horrible scale, I can't quite do accurately. But going up vertically, we do seem to have 10 small squares going vertically, so that means each small square is worth 0.2, so I can put 2.2 right on that line. So the first line after the 2 is going to be 2.2. Please continue, finish the rest of the histogram. Right, so hopefully your final histogram looks something like this. It's got a very tall, thin one towards the middle. There we go, that's part A done. Make sure you've labelled your axes as well. That's our histogram done for part A. Part B, we're going to estimate the number of students under 158 centimetres in height. So remember from part A, I chose to use a constant of proportionality of 1. So in this histogram, the area does equal the frequency. Alright, so in this histogram, area does equal frequency. So if we're estimating the number of students under 158 centimetres in height, have a think, how are we going to do that? Well, hopefully you've come up with the idea of finding the area under the histogram up to 158. So let's find 158 on the horizontal axis. If we had 10 little squares going across, this would be much easier. So it's going to be about there. So to finish off part B, we're going to find the total area to the left of that red line. Number of students under, so that's to the left, 158 centimetres in height. So we've got part of a bar to work out the area of. Just going to shade it in. So this part, it's still a rectangle, so it's going to calculate the width of that bar. We already know its height is 5. And then we're going to add on to that the area of this bar, which is a whole bar. We don't need to actually work out its area because we already know the frequency from that group was 55. So we don't need to go calculating that. We already know that. So the answer is going to be 55 plus whatever the area of this tall and thin rectangle is. Right, now I've drawn a copy of the tall thin rectangle just to make things easier to see. So we know the height of this rectangle is 5 because it comes from that second class which had a frequency density of 5. So we know this is 5. how long or how wide is it? Well, this class begins at 154.5. It starts at 154.5. It goes up to 158. So the class width is going to be what you get when you subtract those two numbers, which is 3.5. So now we can find the area of that part, add it onto 55, and then we have our answer. So we've got 55, remember the whole bar, the first one, add 5 lots of 3.5. The calculator will do the multiplication before it does the addition. So that's 72.5 students. It's only an estimate. I know you can't have half a student, but it's only an estimate. If you want to, you could round that to the nearest whole number. So say approximately 73 students. And that concludes the example.